All right, here is the graph in example 3b. The first thing we're going to do is write down the domain and the range. Okay, we will start with domain. Okay, and remember, we just saw from the previous example that the asymptotes can be really helpful in figuring out domain and range. Okay, so domain, okay, let's look at, we're trying to find like the bad x values. Okay, so you can see that there is a vertical asymptote that's going through x equals -2. Okay, there's also one going through x equals 2. Okay, so I'm highlighting those. If you travel along these red dotted lines, okay, these yellow ones, so like if I'm at x equals -2, okay, this is an x value that has no output. Okay, that's what that vertical asymptote is telling us. Okay, similarly, if you're on the other vertical asymptote at x equals 2, okay, this is an x value that has no y value associated with it. It has no output. Okay, so we can see from these vertical asymptotes that the domain is all real numbers except x equals positive and -2. Okay, those are the bad spots. That's why those asymptotes are there. Okay, so in an interval notation, okay, that's going to be from -infinity. The first bad spot is -2. Get rid of it. Pick up on the other side of -2. Okay, we need to include in the domain all the x values between -2 and +2. Choose the other bad spot, so throw it out with a parentheses. Pick it up on the other side of 2, and then go off to positive infinity. Okay. All right, range. Okay, we need to figure out what y values this graph covers. Okay, again, the asymptotes are going to be helpful here. This time it will be the horizontal asymptote that will help us out. Okay, so here's the horizontal asymptote. Okay, this red dotted line that's in blue. Okay, you can see that this this horizontal asymptote goes through y equals 1. Okay, it intersects the point y equals 1 on the y-axis. Okay, so I'm gonna write that out here. That's y equals 1. Okay, so that's telling us is, you can see like the graph, the blue pieces, they never cross or touch this horizontal line. Okay, this piece over here is getting closer and closer to the red dotted line from this direction. And then this piece is getting closer and closer from this direction. And this middle piece kind of avoids it altogether. Okay, so because the three blue pieces never cross or touch this horizontal asymptote here, we never get a y value of +1. Okay, so the range here is going to be all real numbers except what? Okay, well, y definitely can't be 1 because of the asymptote. Okay, now there is another issue here if you look closely at the graph. Okay, so this piece right here, that if you can see where my cursor is, okay, this leftmost piece, it's getting closer and closer to the horizontal asymptote in this direction, and then it's going up forever. And same thing with this rightmost piece, we're going up forever, and then in this direction we're getting closer and closer to the horizontal asymptote. Okay, so these two middle pieces cover all y values bigger than 1. Okay, this middle piece, okay, if we go from the lowest point on the middle piece, okay, that's going to be -infinity. And then if we go to the high point, that's going to be the origin. Okay, so the highest y value on this piece is going to be 0. Okay, so the middle piece is covering all y values 0 and less. Okay, and you can actually equal 0 here because this middle piece goes through the origin. Okay, so if we're trying, we still need to, you can't rely totally on the asymptotes. They are very helpful, but if you're doing domain, you still need to go from left to right and see what's covered. If you're doing range, you still need to go from the bottom to the top to see what's covered. Okay, so let's go from the bottom to the top here. Okay, the middle piece is the lowest piece on the curve, okay? It covers y values from negative infinity up to 0, including 0, because the middle piece goes through the origin, okay? Then you have this gap, okay? See this gap right here? So in between the origin and the horizontal asymptote, there's no blue curve there. So this gap that I've highlighted in blue, the y values between 0 and 1 are missing, okay? And then after you go above the horizontal asymptote, then you are covered, your y values are covered, y values bigger than 1 are covered by the leftmost and rightmost pieces, okay? So we have a gap in our y values, okay? We leave off at y equals 0, and then we pick up again after the horizontal asymptote. Okay, so then the leftmost piece and the rightmost piece are going to cover y values strictly bigger than 1. Okay, so this is what the range is for this particular curve. Okay, all right, the next thing we need to do is write down intercepts. Okay, so let's look for any x-intercepts. Okay, if we're traveling here, let me try to use a different color. So let's see here. Let me pick this. Okay, so in purple, I'm going to travel along the x-axis here. Okay, and we see that the blue curve intersects the blue curve intersects the x-axis in one point, the origin. Okay, so the origin is going to be an x-intercept here. Okay, so similarly, now we need to look at the y-axis to write down any kind of y-intercept here. Okay, so if we travel along the y-axis, okay, we're going to hit the blue curve in one spot. Again, it's the origin. Okay, so the x and y intercepts here are both the origin. Okay. All right, what do we have to write down next? Okay, let's go back to our long list here. So we've done domain and range, we've done intercepts. We need to write down the equations of the horizontal asymptotes. Okay, so we definitely have horizontal asymptotes. We have two of them. Those are the, I'm thinking vertical here. Hello, horizontal asymptotes. That's left to right. Okay, we've got one horizontal asymptote, and that is going to be in blue. Okay, so here we go. I'll highlight this in blue. So this blue line is your horizontal asymptote, and we already said that that has the equation y equals 1. Okay, horizontal lines are always y equals. Okay, any point on the blue line, the one that I've highlighted in blue, it is going to have a y value of 1. Okay, so now let's write down the vertical asymptotes. Okay, we have two of those. Those are the guys up and down in yellow. Okay. All right. So we've talked about these already as well. This leftmost one goes through the point x equals -2 on the x-axis. The rightmost one goes through the point x equals 2 on the x-axis. So these are the equations of the vertical asymptotes. X equals -2, and then also x equals +2. You have to write your asymptotes as equations. Okay, if it is horizontal, it is y equals. If it is vertical, if it is horizontal, it is y equals. If it is vertical, it is x equals. On these two yellow lines, no matter what point you pick, okay, it will have the appropriate x coordinate. So like the leftmost vertical asymptote, any point on it will have an x value of -2. If you look at the rightmost asymptote, the vertical asymptote here, if you pick any point on this yellow line, it's going to have an x coordinate of +2. Okay, the last thing we need to look for are oblique asymptotes. Okay, if you have an oblique asymptote, you would recognize it. You would see a red dotted line. That's a line with slope. Okay, a non-horizontal line and a non-vertical line. We don't have any of that here. Okay, so there's no oblique asymptote here. Okay, and let me go back to my checklist. I think we've got everything. We did domain, range, intercepts, horizontal, vertical, and oblique asymptotes. Okay, so here are all the characteristics that are asked for in example 3B.